So this video is to help you in completing Lab 2, the metric and American conversions for the pre-lab portion. So the lab portion, how to collect the data and fill out the lab portion of this lab, has been posted in a different video. So this is just for the pre-lab. I'm going to focus on the conversion part of this lab. So looking at the first question of the pre-lab, we have a 50 milliliter beaker has a mass of 42.503 grams. Make the following conversions and show your work. All right, so what I want to point out in this first question is a lot of students find it confusing because there's two different numbers present in the question. So this 50 milliliters that's written, that is just the size of the flask, the size of the beaker. Okay, we're not going to be using that number at all to do conversions with. So you can ignore that number. It's just telling you what size beaker has a mass of 42.503 grams. So this number, the mass, we're going to be taking that and we're going to convert that number. So we're going to take 42.503 grams and we're first going to convert it into kilograms. Now to do that, there's two different ways to do it. One is by looking at the conversion factor sheet for metric to metric conversions. And so the reason I know it's metric to metric, because that's the first step, right, is figuring out if it's metric to metric or if it's English to metric. You look for what's in common. So here I have G for grams, and then I have kg again for kilograms. So GG, that means it's metric to metric. If there were no letters in common, it would have been English to metric. So since it's metric to metric, I can use a shortcut, this KHD space DCM. And what these are symbols for the prefixes of the metric system. So we have kilo, hecta, deca, blank, deci, centi, milli. So when we use this shortcut way, this blank spot, that is where the unit of measurement that we're using goes. So if we're talking about volume, an L would go there for liters. If we're talking about time, an S would go there for seconds. But in this case, the letter we said we had in common was G for grams. So we're talking about mass, so a G for grams is going to go in that base. Now we're starting at the G because that's what the original number given to us was in, 42.503 grams. And we want to go to the K. So we want to go over here to where the K is. So start at the G, and then to get to the K, we're going to move that decimal 1, 2, 3 times to the left. We're going to do the same thing to this number. Starting at the decimal, which is between the 2 and the 5, we're going to move it 3 times to the left. So 1, 2, 3. So this is where our new decimal is, now that it's in kilograms. So what's going to go in that empty space? A 0. So 42.503 grams is going to be 0.042503 kilograms. So this would be your answer in kilograms. Now notice I kept all of the digits. Why did I do that? Because you need to check significant figures. So in the original number, 42.503, all of those digits are significant. 4, 2, and 5 are all non-zero numbers, so they count. That 0 counts because it's between two non-zero numbers and because there's a decimal point. Okay, so all 5 of those are significant. So since we have 5 significant figures in the original number, our conversion number answer will have 5 significant figures. So that means when you work through the rest of these problems for number 1, every one of these answers should have 5 significant figures. Okay, so you're going to go through now and change 42.503 grams into pounds, then into tons, then into decigrams. Right? Same thing goes for number 2 here. So once again, it gives us two numbers, 10 milliliters and 7.12 inches. That 10 milliliters, it's just telling us what size of graduated cylinder is that height. So we're not converting that 10. It's the 7.12. That's the number we're going to start with to convert. So let me do this height in centimeters to show you an English to metric one quickly. So you're going to take that 7.12 inches. For this first one, you're going to convert it to meters. The second one has you convert it to centimeters, and that's the one I'm going to work on now. So I'm going to write it inches to centimeters. Now in this case, it's English to metric because there's no letter in common. So with English to metric, you need a conversion factor. And this would be one of the conversion factors you would find on your conversion factor sheet. Okay, so it's not something I expect you to memorize, it's something you'd have to look for on your conversion factor sheet. So to convert this, since it's English to metric, we can't just move the decimal point. We have to do what I call railroad tracks. So you're going to take the original number, always start with the number given, which was the 7.12. Don't forget your units. And I'm going to make a little railroad track here. Now what's going to go in this empty spot is this conversion factor. And conversion factors can be written two ways. So I can write this as a fraction with the centimeters on top, or I can write it with the inches on top. They mean the same thing. So I have to figure out which one of these two ways is going to work to put here. So imagine picking these up and putting them in this empty space. Now the key is that since inches is in the numerator here, you want inches to be down here in the denominator so that they're on opposite sides of this horizontal line so that they cancel. So the one that's going to work out of these two is going to be this guy here, because you have the inches in the denominator, so you can put that down here so that the inches cancel, and then the centimeters in the numerator up top here. That way, inches have canceled and centimeters will be your answer. So to solve, remember, as you go across, these vertical lines are multiplication signs. So to solve, you will take 7.12 multiplied by 2.54. And since there's just a 1 in the denominator, you're just dividing by 1. When you enter that into your calculator, make sure that you are using significant figures. So you have to look to the original number, that 7.12, and figure out how many significant figures are in that number. They're all non-zero, so it's going to be 3 sig figs. So whatever my answer is, I want to stop at 3 sig figs. So my calculator shows this number here. If you put that number in this blank for height in centimeters, it is incorrect because it does not have the correct number of sig figs. Remember, we want to stop at 3. So you're going to go 1, 2, 3. So you want to stop one spot after the decimal point. Always look to the number next to it. If it's a 5 or higher, you're going to round up. So in this case, it's going to be 18.1 centimeters. So that is the correct answer to place in the height in centimeters column. So every answer under number 2 should have 3 significant figures. All right, let's look at the last one now. So you may have seen an example of this one in the lab video if you've watched it yet, the lab data collection video. So this one's a little different because we're using a percent error calculation. So the key here is to read this word problem and figure out what is the accepted value and what is the experimental value. And then you just plug in the appropriate numbers. So the accepted value, that is going to be the true value, the correct value, the accurate value. So read the word problem and figure out which one of those numbers is the true, accurate, accepted, measured value. The experimental value, that's usually the guess. What the student guessed, what they thought, what the student came up with, so not the true value. So you're going to figure out which is which and then plug those numbers in. This is absolute value signs, so make sure that if you do get a negative number that you change it to a positive. That's what absolute value means. It means positive. So you'll subtract the accepted from the experimental, make it a positive, and then divide it by the accepted. Don't forget to multiply by 100 so that you get a percent. That's how you get the percent, is by multiplying by 100. I hope this helped you work through the pre-lab for Lab 2. Let me know if you have any other questions. Thanks.